record on this computer. All right, so let me, so last time we were talking about the new keyword and arrays in Java, things like that, right? We kind of had this sample document where we already have some like Java code. Maybe our goal up to this point has been, hey, let's take our Python knowledge and sort of convert it over to Java. So at this point, is it fair to say that we feel like Java looks familiar enough that if we got thrown into the deep end, we could sort of kind of figure it out with some examples? Is that fair enough when we start looking at classes, things like that? Because we've written an if statement. Not that I'm asking you, I mean, I'm going to give you sample code. That's what I'm saying. But we have an understanding of programming enough now where we can see the similarities between Python and Java, hopefully fairly clearly. We just are lacking practice in actually writing that. Fair enough statement? All right, so we've already looked at conditionals. I kind of jumped around the slides here. I'm going to actually show you this idea of curly braces are not required once we kind of get into some code. Actually, let me do it now just as a connection piece to the indenting. So if I come over here, this is our project, right? All right, I'm going to go ahead and get rid of all this stuff in here. If I put that up on Slack, I think I put that code up on Slack, didn't I?
Yeah, it's up there.
Okay. So we'll go ahead and get this. All right. So what we're going to do here is we're going to create a scenario, kind of an if statement. So we're going to say int age is equal to, actually, let's say int a is equal to 5. We'll say if a is less than 10. Now, when I write this, I always put an opening curly brace, and then when you press enter, Eclipse goes ahead and puts the closing curly brace that corresponds to it. And we'll do a system.out.println. A is less than 10, something like that. And then we'll go ahead and right after this if statement, we'll say after the if statement, like that. Okay, so we start off A is 5. Is 5 less than 10? Yes, it is. So we're going to go ahead and print out A is less than 10. Now, this line here always happens. It's not related to this if statement. Hopefully you can kind of see that by the structure I've written here because I purposely indented, even though Python or Java doesn't care if I indent, but that should be something we're practiced at doing from Python because it forced indentation on us. All right. So I'm going to make the argument that this opening and closing curly brace are never wrong, but technically, so let me, but technically, so I'll go ahead and run this. So we should see A is less than 10, and then we'll also see after the if statement. All right, so we say A is less than 10, and we also see after the if statement. I'll go ahead and change A to 50. So now this if statement will boil down to false. So we will not print out A is less than 10, but we'll still print out after the if statement. Same thing as would happen in Python. But now if we try to do everything off the indentation thing, so let's say we're used to the Python way of doing things. We leave the curly braces out. At a glance, we look at this and say, oh, well, these two lines both belong to this if statement, correct? And if we run it right now where A is 5 less than 10? Yep. it'll go ahead and print out A is less than 10. It'll also print out after the if statement. Both of those things print. So at that point, we might be lulled into thinking that, oh, well, this guy is part of that if statement. But if we change A to 50, through Python eyes, we might say, well, because 50 is not less than 10, none of this will happen. But the reality is this second thing still does happen after the if statement. The indentation piece here is not something that Java cares about. When you write an if statement or a loop in Java, the syntax is if Boolean expression followed by a statement. Statements can be one line of code like this. This is a statement. Or what's commonly used is a block statement. That is a statement that starts with an opening curly brace and ends with a closing curly brace. And everything that's inside of that gets processed sequentially. Okay? So what I'm saying here is that it's never wrong to say, I will always use a block statement as the body of my loops, as the body of my conditionals. All right. Even if you're only going to put one statement in there, it's not wrong to put it inside of curly braces. And I think it gives you some structure to what's going on here. But it's technically not required, because all that's required for the body of this if statement is a single statement. But if I want to do multiple things, I need to use a block statement to house multiple things inside of, think of it like a garbage bag. All right. So my argument is, for your intents and purposes, just assume that the syntax is if Boolean expression, opening curly brace, list of statements, closing curly brace. Okay. Back over to Keynote here. Talked about this curly brace thing. That's what we just talked about. All right, so there's some stuff there. We've already seen some of this iteration stuff. We'll just see it through examples. Let's go ahead and look at the plus, plus, and minus, minus operator here. So if I say system.out.println A++, it's going to print out a 50. And we'll see what I mean here. I'll go ahead and print it on the next line. So it's going to print out a 50 here because A started as 50. When the plus plus comes after the variable, the incrementing happens after the value is resolved. Okay, so this guy right here, this is what I have highlighted, says boil down to the current value of A and then increment A by 1 after you've boiled down to the current value. So we'll get a 50 out of this here, and we'll see a 51 here. And all that happened because the plus plus came after the A. If I put that plus plus before the A, then what do you think happens? It increments immediately. It increments before giving you the value. So we'll get a 51 and then a 51. Does that make sense?
I got a question.
Go ahead.
Is it kind of like that plus equal to thing in Python where it like loops through and then it just adds 1 every time?
Well, yeah, but so this adds 1 exactly. Where what you're talking about is the A plus equals 1, something like that.
Yeah.
All right, so A plus equals 1 is the same thing as saying A plus plus. I'm sorry, it's the same thing as saying plus plus A. So this guy equals plus plus A. We saw it just gave us a 51. The difference here, though, is is that with the plus equals, the compound operator, I'm not forced to only increment by 1. I can increment by 2 if I want to.
Okay.
Okay. You cannot do that with the plus plus operator. Some people might say, well, can't I just say a plus 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 plus? A plus 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 plus? Just keep throwing pluses on there and everything's fine? Now, the answer is no, but we should know why the answer is no. We just printed out what a plus plus was. A plus plus came out to be the number 50, right? We know it had side effects. We know it actually ultimately did change the value of a. But we saw that a plus plus, this guy right here, ultimately boiled down to the number 50. So when you say a plus 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 plus, you're effectively saying 50 plus plus. We are trying to redefine the constant value 50, which is not allowed. Once a number exists, it stays that way. I can't tell you that the number 3 now actually means the same thing as the number 5 in your head and go through the rest of the day with that in mind. Although I've seen some of those hypnotists on TV that do that. You seen those things? Where they like tell them that something, like every single time you hear like the word bird or something like that, you're supposed to like caw like a crow. And like they'll just be talking about something, all of a sudden they'll just say bird. Is that real? My dad got called up on stage a bunch of years ago in Vegas and was in one of those things. And to this day, we're not sure if he was faking it or not, but they had him doing some things. So in any case, the plus plus operator requires there to be a variable in front of it, because effectively what we're doing here is we're saying a is equal to a plus 1, or similarly, a plus equals 1. Okay? That's what that thing is doing. It's shorthand for incrementing, or you can use minus minus, decrementing by 1. All right, so just like I just gave you the rule of thumb for the curly braces, effectively always use curly braces and you won't screw up, okay? I would say never do something like this. Now, it's important from an academic perspective that we should understand when the plus plus comes after, it gives you the current value and then increments. When the plus plus comes before, it'll increment first and then give you the updated value. But what would happen if I just said a plus plus right here and then I printed out a? If I said a plus plus right here and I print out a, I'm going to get a 51, right? If I say plus plus a and then I printed out a, I'm going to get a 51. If I say a plus equals 1 and then I print out a, I'm going to get a 51. If you put it on its own line, then you don't have to play this game about, well, does it happen before? Does it have to happen after? Not that it's a really hard concept to wrap your mind around, right? The plus plus comes after, it happens after. If the plus plus comes before, it happens before. But nobody's overly impressed if you say, well, technically after this line, I would have otherwise said a plus plus after that line. Maybe you want to write this code. All right, and you just decide, you know what, because I know what I'm doing and people think I'm cooler, people say that, right? You'll just go ahead and embed it inside the line above, because technically that means the same thing. I would argue that this is always bad programming practice. You'll see plenty of examples of this, but nobody's impressed if you save one line of code. Every now and then you might run into a situation where doing the incrementing inline like this might be beneficial, but let's call that like 1% of the time. Most of the time, if you want to change the value of a number, typically by 1, I mean, where you see this most often is like in our stock for loop. For int I is equal to 0, I is less than 10, I plus plus, right? So you see I plus plus there pretty often. That's where you see it all the time, okay? Questions about the plus plus minus minus operator? Realistically, I would probably never ask you on a test or something like that the difference between those. It's not that I think it's completely unimportant. I just don't want to waste a question on something like that. You should know that because it's something, especially when you're looking at documentation, especially older documentation from like C and C++. On Java, you look at examples and things like that. You will see programmers do this in line, and it will kind of come from that place of, well, I did it in line just because you can. And I would say that this came from a very similar place from why you'll see code examples that omit curly braces, or you'll see code examples that do this, where the opening curly brace is on the line with the for loop or with the function, as opposed to over here left justified. It's because they needed to save a line of text in a book that was printed, right? Well, for years, I mean, when I first started teaching, we didn't necessarily have, pages and pages of stuff online with all sorts of code examples. You had a textbook that had this stuff in it, and pages are only so big, right? And they got to adhere to some sort of font standard so you can actually read it. So they would do things to save space, and then those things ended up becoming standards. And it's not that they're all bad. We saw this a couple classes ago that Java's perfectly happy with you putting the entire program on one line. Human beings can't really read it, but Java's okay with it, right? All right. So again, I'm not going to take points off. I'm not going to say, well, your curly braces really should be like this. But I'm giving you kind of like a best practices approach to write code that'll be less error prone by always using curly braces, so that things you want to be connected to the if statement or the for loop, put them inside the curly braces. If you don't want it to be connected to it, put it after the curly braces, so on and so forth. If you don't want to have to guess how a number gets incremented, do the plus plus or the minus minus on a line by itself. So no matter whether you had it before or after that line, the value's changed. Okay, questions about any of that? All right. So, I have this all in the slides. You can go through and read that for inner meaning if you want. There's our for loop example as well. Okay. So that may or may not be our first programming assignment. I'll need to look at that. Let me just see what it is. Okay. So let's look at methods or functions. So I'm going to go ahead and we're going to write a function in here. And let's go ahead and do something we wrote last semester. We wrote like the reverse string function, right? So we're going to write a function that's going to take in a string as a parameter. It's going to build a brand new string that is the reverse of the original string. Okay. Now, some of you, well, one thing to kind of look forward to is while Java does have some built-in things to let you do some of the stuff like that, I encourage you for the first while, maybe your first several years of programming, write as much of the stuff yourself as you can until you become bored of doing that. So you may have seen some comments on like the final exam last semester in Python where I had you write that reverse function, right? And some of you wrote that little shortcut version of it. We had little, you had the little curly braces or the little square brackets. You put the :-1, and it did the reverse, which is all fine and dandy because the output was correct, but you didn't show that you actually you knew how to write the logic. I didn't take points off because I didn't necessarily say don't do it with the shortcut method. I'm just saying that you're only hurting yourself if you find solutions that happen to work, but you don't necessarily understand how you can write something custom on your own. Maybe somebody says, reverse it, but do something, another little twist on it. So that built-in thing doesn't quite accomplish what you needed to accomplish, but now you haven't practiced writing logic yourself. Okay, the title of this class is Coding to Algorithms, right? So we happen to be converting our knowledge from Python over to Java, but we're going to be focused on writing algorithms to do different things. We're going to be looking at a lot of searching and sorting algorithms in here. All right. But let's go ahead and let's write a function just like we had last semester where it's a reusable chunk of code that we write once and can call multiple times. All right, so I'm going to go ahead and I'm going to put the keyword static in front of this. And for right now, just always put static in front of it until we talk about that being something different. All right, we're just going to say that's a required. Now, this is a strongly typed languages, so different than Python. When we write a function, we have to define the kind of value that function is going to return. So in this case, our intention is to write a function that called reverse, or called reverse string, let's say, that takes a string as a parameter and returns a string. All right, so we're going to be returning a string from this guy. We'll call this function reverse string. And then it takes its parameter list and it's going to take in a parameter of type string. Again, it's a strongly typed language, so we have to specify what kind of value we expect S to be, right? Where in Python, we would have written def reverse string S, colon, kick it down a line. So those two things are kind of the method header equivalents to each other, but we're seeing the difference between a loosely typed language like Python and a strongly typed language like Java, where we have, here's what it returns, here's what it takes as a parameter. If you have a function that's not going to return a value, you put void in front. Notice that the red squiggly went away when I put void in front. When I have string in front of it like that, red squiggly's back. Why do you think that is? First of all, Eclipse is trying to help you out. This isn't the actual compiler. So it's trying to, clue you in when kind of like Microsoft Word, when you have a spelling error or a grammar error, it puts little squigglies. Sometimes it doesn't know the word you're using if it's in a different language or you've hyphenated something that's not supposed to be hyphenated or whatever. But I got the red squiggly here. Why do you suspect I have this red squiggly? Nope. Now, if you hover over it, it will tell you. Go ahead. Yep. In Java, if we've advertised we're going to return a value, we have to return a value. So right now, I have advertised I'm going to be spitting a string out here. When all is said and done, I'm returning a string. The name of this function is reverse string. I take a string to work, but nowhere in here have I actually returned a string yet. So if I just go in and I return the empty string, now the squiggly will go away. It's happy again because I fulfilled my promise, right? My promise was I will return a string. Make sense? Okay. But logically, this isn't the string we intend to return. The string we intend to return is whatever string was passed in here. Okay, that was another weakness from the exams last semester was a lot of you like to hard code values in there, right? You'll come in and right off the bat, you just say, well, S is hello. Now, S is whoever called your function, it's whatever they passed it. So if I call reverse string up here, and I pass it hello, like that, S will come in as hello. Another, and we said this last semester, but if you find yourself doing something like this, about 104% chance you're doing it wrong. It's a real number. I'm rounding down. All right. Parameters are meant for the purpose of having a function that we write one time but can reuse it. That means that this guy serves as an input. So I can call reverse string. Copy it. Yep. Multiple times, passing it different inputs. This first time, hello is coming in for S. This second time, world is coming in for S. It's not appropriate for us to immediately overwrite S with some other value, whatever that value is, because then we're just ignoring the inputs. Okay, so if you find yourself changing the value of your input, you're probably doing it wrong. Now, here would be an example, not necessarily for reverse string, but here's an example of when this might be a line that sort of kind of makes sense. Let's say that you are taking in a string, but you want it to be case insensitive. So you can say, I still got to fix this. There's something going on with my Eclipse, probably a weird setting thing. So I can say to uppercase here. So inside the string class, there exists a to uppercase method. You want to take a guess at what that method does? Maybe converts string to uppercase. All right. So what is this doing? I'm setting s equal to the guaranteed uppercase version of itself. So maybe the program I'm writing, maybe this function, maybe it relies on just, I'm going to assume everything's in uppercase. If you passed it to me in lowercase, no problem. I'll just convert it to uppercase. If you passed it to me in uppercase, no problem. I'll convert it to uppercase from uppercase. I haven't done anything, but after this line of code, I'm guaranteed that S is in uppercase. Make sense? So maybe that's an example when you might want to do a little bit of manipulation to the parameter that was coming in. But if you find yourself hard coding it to a new value, you're probably going down a bad path. That's not the purpose of parameters. Parameters are inputs to this function. Okay, so we're going to take in S. Our goal here is to reverse that string. This isn't really, the logic behind this isn't any different than we dealt with in Python, right? So we're going to be building up a new string that is the original string in reverse. So I'm going to create maybe a string answer that started off as the empty string. I'm going to walk my string S from the end to the beginning. You could also go forwards, but I'm going to walk it from the end to the beginning. So I'm going to say for int I is equal to answer.length minus 1. That is the position of the last legal bucket in S. Okay? That's the same thing as saying len parenthesis S minus 1 in Python. I'm going to keep going as long as I is greater than or equal to 0. And each time through, I will decrement by 1. So the Python version of this would have been for I in range length answer minus 1 to -1 step by -1. Remember that guy? So this is the Java equivalent of this line. This takes a variable I on a voyage between the length, the last legal bucket, length of answer minus 1. And it's actually not length of answer, it's length of S. Sorry. Minus 1 all the way down to and including 0, subtracting 1 each time. All right, that makes sense? And what are we going to do? We're going to say answer is equal to answer concatenated with s dot charat I. Then we'll return our answer. So this should look pretty familiar to us, even though it's using a little bit different syntax. The logic is basically what we wrote last semester, right? Okay, loop through every character in S, starting at the end, going towards the beginning, build up a new string. So this line in here is the same in Python. This would have been answer is equal to answer concatenated with S at I. No semicolon, like that. In the end, we'll go ahead and return our answer. All right, questions about this syntax at all? And the way you'll convert your Python knowledge to Java knowledge is by writing the syntax. When you look at it, you should say, oh yeah, those look equivalent. There's some squigglies when there's some zigs where there used to be zags, stuff like that. But otherwise, it seems to be largely the same thing. Okay, you just got to get used to it. So what will the output of this program be? When I run this, what will it be? And I'm trying to trick you. That's the heads up.
Is it going to be the place of memory for answer?
The place in memory for answer. No, but I'll give you a hint. All programs begin and end with main. What does main tell me I should do here? What am I doing in main? I have 2 lines in there, right? I'm calling a reverse string on hello. Then I'm calling reverse string on world. What does reverse string do? Reverse string builds up answer to be the reverse of the string that was passed in, right? And then I'm returning answer. What am I doing with the value that was returned here?
Nothing.
Nothing. So the output of this program is going to be nothing. Now, I could do something with it. I could print it, right? So I could throw a system.out.println in front of this guy. Do the same thing down here. So now, well, let's just do it for that first one. So now I'm going to take whatever value this guy boils down to, which presumably should be hello in reverse, and I'm going to display it to the screen. So there's my hello in reverse. But I'm still not doing anything with this guy. So maybe this guy, I say string result is equal to whatever's returned by it. And then I do a system.out.println result. This would then let me use that string multiple times for other things. So I can say system.out.println result.toUppercase, something like that. So now I get world in reverse and then the uppercase version of world in reverse. I was able to use it twice because I stored the result of calling that function on world in a variable, and then I printed out the contents of that variable, and then I also printed out that variable converted to uppercase. Notice that toUppercase returns a copy of that string in uppercase. It's not a permanent change. So if I printed out result again, it would be lowercase again. So this guy just gives me a version of the string result in uppercase. It does not permanently change result to be the uppercase version of itself. If I wanted to do that, I would have had to say result is equal to result.toUppercase. Then I can waste my time converting an uppercase thing to uppercase if I wanted to, but then we'll see it's also permanent. All right, so make some sense? This is the syntax for a function in Python, or I'm sorry, a function in Java. So if we were putting generic syntax in here, it would look like this. We would say return type. For right now, all of our functions will have static in front of them, but only for a very short period of time because we're going to quickly move over to objects because we've already learned about object-oriented programming in the previous class. We're just learning the Java way of writing it. But for right now, for the next, let's call it 1 or 2 class periods, we're going to have static in front of all of our methods. All right, so we put static, then we have the return type, then we have the method name, open parenthesis, comma, delim params, and we'll say with type. And then opening curly brace, body, closing curly brace. All right, that's the syntax for a method in Java. All right, questions about this guy?
Yeah, why is the answer equals answer plus s charat and separate curly brace?
What do you mean? You talk about the parentheses here?
No, like you see you have string answer, then yeah, that part.
Okay, yeah. So This is the body of the for loop. So like we talked about earlier today, for loops, just like if statements, they do not require the curly braces, but it's never wrong to put the curly braces. So because I want this to happen as part of this for loop, I'm putting an open, this is the body of that for loop. This is the body of this entire method. And this for loop happens to live inside of that method. All right, if we were writing this in Python, I'll just actually write it, the whole thing in Python on another line. So we would say define reverse string S, then we'd indent, we'd say answer is equal to the empty string. Then we'd say for I in range, length of S minus 1, down to not including -1, step by -1, colon, answer is equal to answer plus S at bucket I, return answer. All right, that's the equivalent in Python. Notice here that this answer thing has to be indented underneath the for loop in Python. In Java, it does not have to be indented under there. So the way we are saying this stuff belongs to this guy is by housing it inside of this block statement, the opening and closing curly brace. It would be legal, since we're only doing one thing in there, it would be legal for me to do that. But keep in mind that this is the same thing as this, which is the same thing as this. If you look at that code right here, you would say, that looks weird. I'm telling you from Java's perspective, the statement immediately following a for loop belongs to the body of that for loop, regardless of indentation. I don't even have to have it on a different line. That's fine too. All right, so we have those curly braces because we're not forced to indent in Java, but we choose as good programmers to have code that's readable by human beings. So unless we have a very, very, very good reason not to, and because we know what we're doing, we should always have an opening and closing curly brace following a if statement or a for loop or a while loop, and then have the body of that for loop or while loop or if statement indented within the opening and closing curly brace. That allows us to have code that is equally readable to what we would have seen in Python that Python used to force us to do. Right? Python forced indentation. All right, other questions?
I had a question.
Yep.
So like in Python, you'd have to create your function before you used it, correct? Like earlier in the code?
Yeah, technically you wouldn't have to, because Python uses a two-pass interpreter. We typically did.
Okay, yeah, that's what I was wondering, because right here you're calling it and then writing it.
Yeah,
I was just wondering.
We typically did write in Python. We wrote all of our functions at the top, and then we called them inside of main at the bottom. And you certainly could do that. Main does not have to come first here. Yeah.
Okay.
So nothing is stopping us from. I'll just take all of this, and we'll put it before main, and it'll still work. All programs begin and end with main. Doesn't matter where main was inside of our driver class. And Python would be the same thing. But it's a good question, because some older languages would not work the same way. Some older languages used either for a compile language, you would have used what's called a one-pass compiler. For a interpreter language, it would have been, I guess, a pre-pass interpreter or a post-pass interpreter, where anything you were going to use later on in the program, you needed to have previously defined and bumped into later on in the program. Now, that's still true for variables. For instance, I can't define answer after I've used answer. I can't do that. Notice it's not happy here. It's saying, hey, I don't know what you're talking about. Now, if we were in Python, Python would let us get away with this and say, because you can build variables out of nowhere, right? You'd have to deal with whatever the default value for answer was, but no harm, no foul. But in Java, if you're going to create a variable, you need to create it before you intend to use it. Load it with any starting value you're going to need for that problem, and then you actually use it. So, but that has more to do with programming logic than the language itself. If you're going to create a variable to use in your code, you need to make the variable before you use the variable. Okay? But Java and Python, they don't care whether you put your functions before or after main. Historically, main has come first when you look at sample programs. That way, when you go into, well, first of all, what we're seeing right here is usually not what a Java program is going to end up looking like, because typically we're going to be writing object-oriented stuff in Java. So the entire contents of driver is probably just going to be a main. Think of this as like the conductor at an orchestra, right? You know, everything starts with this. We start at line 6 here, and we just do whatever this code tells us to do. And we're probably leveraging logic that lives in a different class, different place. Okay? I can even show you that. So I'll go ahead. How are we doing on time? That's fine. And you don't need to do this for your first assignment here that we're going to have for Monday, but I'll at least show you that it exists. It's really the same thing. Nothing's going to change. So we're going to call this guy my string factory. Okay, because this guy is going to be built for doing things to strings in our little example here. So I have a class called my string factory. Now remember, I said all programs begin and end with main. Well, now this one program has more than one file in it, more than one class. So the one that I intend to run, the one that's driving my program, is going to be driver. This is the one I'm going to put that main method in. So these other guys are used for supporting actors, supporting material. So what I'm going to go ahead and do is I'm going to go ahead and, let's see, can I get back here? I'm just going to steal all this code. And we'll paste it in here. So inside of my string factory, I have now created my reverse string method. Same exact code as we had before. But now no longer does it live locally in the file we were in before. It now lives in a thing called my string factory. Okay. Now it's still static, so just kind of let me get away with that for right now. I'm just going to show you how to call this, but I haven't rewritten any of the code, right? I just moved it. I've reorganized where I put it. So then in driver, it's no longer reverse string being referenced locally. And there was actually a hidden thing here called driver.reverse string that we would have seen before. But now I'm saying, actually, that reverse string function, it lives inside of my string factory. I housed that code in this other class called my string factory. And inside of my string factory, we have this static method. The foreshadowing of this is static means it belongs to the class. So we call it using the name of the class in which it was defined. So we're just doing it by example right now, but when we see the alternative to that, probably next week, you'll see the difference. We won't use the keyword static, we'll have to call it a little differently. All right, so now I've kind of sucked those function or that function into my string factory that does things to strings. In this case, it reverses a string. And then over here, I call upon my string factory's reverse string ability. So this is probably fairly common for what you might see main looking like. Main is like our orchestra conductor, where it says this is all the stuff you're going to do, but it might go and grab abilities from other files. Make sense? So we end up having a little bit more, maybe more modular programs that looks more modular, better organized, but it's the same thing as we just had a few minutes ago. I've just moved some of that code inside this other thing. It gets back to the idea of the object-oriented telephone, right? This is our object-oriented telephone. We know all those wires are inside there, but it's hidden from us. So what do we actually see? We just actually see the part of the program that's running, part of the thing that's publicly being used. And these wires are hidden inside of this class over here. All right, make some sense? All right, so let's look at this first homework assignment. So write a Java program that defines a string variable and then creates a loop that goes through every character in the string and counts the number of vowels that it finds. Okay, so A, E, I, O, U, upper and lower case. Display the vowel count to the screen. Your string variable should hold the name of one of the Bible books in the New Testament. So for example, if you held, if the variable was Matthew, your program should display 2 since there are 2 vowels in that string. Now, we have not covered GitHub yet. I'm going to probably cover that next week. So for right now, I actually think it's in the slides up higher, but for right now, let's just say submit a screenshot of the code. I'll put that in the thing on Blackboard, but just do a screenshot of it and the self-evaluation. Something that you will find helpful. Actually, no, I don't want to give you the shortcut. I want you to write the logic to figure it out. Using only the tools we've done so far. I'm not asking you to invent time travel. It's not that big a thing I'm asking you to do, but when we get to class on Monday, I'll kind of show you a shortcut version of this. So for right now, for those of you who might go and look it up, I'm going to say you cannot use the index of function. This is like find in. Actually, did I introduce index of in here already? I don't remember. Do you remember seeing it? I don't think so. So this is like find in Python. But you can't use it for this assignment. So write a function that determines if a character is a vowel or not. Make sense? So for Monday, first programming assignment, I'm going to actually write a thing. I'm going to show you GitHub in class on Monday. As we start having these programs that have multiple classes in them, it's going to start becoming more unwieldy for you to turn in like screenshots and stuff. So what we'll end up doing is actually upload our code into this remote repository, and then you'll give me a link to your repository. That's something called GitHub. Okay? Questions, comments, concerns, bribes?
Can you do a dot lowercase like you did a dot uppercase? Would that be the same thing? Except for obviously replace the word.
Yep.
All right.
And pretty soon here, I'm going to be showing you how to read the Java documentation. That's part of that conversation when we go from static versus non-static methods. So for right now, just kind of have it operate off of, this is the way you write a method, how I've shown you so far, so I can give you then context for the alternatives. But like you just asked about 2 lowercase, I promise you there's about 50 other things strings know how to do beyond 2 uppercase and 2 lowercase and char at and index of. They know how to do a whole bunch of stuff. And by learning how to call those, you'll be able to unlock all those things. All right, I'll see everybody on Monday. Have a good weekend.